Hello everyone, my name is Peter Schaknat. I am the Managing Director of Schaknat Electronic GmbH, and today we are optimizing a new Mercedes-Benz Arocs 3748. Here we have the Mercedes-Benz Arocs, a really awesome chassis, V-axle chassis, heavy-duty body, heavy axles. As you can see, this is a 37 to 48 brand new vehicle, third generation engine, OM471 engine, 12.8 liters displacement with 2,300 Newton meters of torque. The engine is available up to 530 horsepower with 2,600 Newton meters. The Equiway already has the brand new transmission, the revised gearbox with the new shifting strategy. So Mercedes-Benz has also done a lot in the eco sector to make the consumers even more efficient. They've also made several changes to the engine, such as reducing internal engine resistance. So the engine has been modified once again. In fact, with the customers we've already spoken to, with the new engine gradation 3, which has been available since January 2023, the factory fuel consumption figures are already significantly better. The customer uses it on construction sites. He uses a hook lift here, so for heavy containers. That's precisely why it has such a heavy body, because it's designed to handle the very heavy axles. So today, I just wanted to quickly show you exactly how much power a truck actually loses from the engine all the way to the first driven axle. So you can get an idea, because here we have a long drive shaft, a transfer case, the heavy axle, so external planetary axles, as opposed to stub axles, the lighter axles, just so you can see what actually happens there. We will do initial measurements and then use our Schaknat app to optimize the vehicle again. As you know from the other videos, you can optimize the engine and transmission yourself again. You can also read and clear the error memory, which is a cool feature. Especially when you're on the road and there's some kind of problem, you can do your own error diagnosis. So I'd say let's get started. As you can see, we've already driven it onto the platform. We're measuring again at this axle here. So now we're going to measure wheel power. On the first driven axle, we lock it through, meaning we lock the drive so that both axles are synchronized. You can see the outer planet gears here. This axle here is spinning freely, so the roller is just spinning freely here. I'll add that in later, but I'll explain it to you on the monitor. The other guy, my colleague, is going to unstrap the vehicle now. Of course, for him it's also awesome to strap down a chassis like this. That's what he's doing now. We're pulling it off at the back, with both axles coming down nicely. Obviously, it's a new vehicle, and it costs a lot of money, so we have to make sure nothing happens to it. He's cleaning it up now, and then I'd say we'll do the initial measurement and see each other again at the monitor. I just wanted to quickly show you the chassis from underneath so you can see what it looks like down in our inspection pit. You can see here, up at the engine, the oil pan goes through to the transmission, so you can see how slowly the drive shaft is turning. Well, I think so, yes. That's easily a 3 to 3.5 meter drive shaft. With a piece like this in between, you can see that's something people shouldn't forget. It actually causes a loss of power. With a 6x4 axle configuration like you see here, and with such an exceptionally long wheelbase, of course, from the engine located at the front all the way to the final driven axle at the very back, you are naturally going to have a significant amount of power loss. That's something we'll take a closer look at right now. Now up here we can see the exhaust system again. This is brand new Aero 6E technology, so it's the latest standard as well. You can still see it coming out to the side at the bottom, so it really is the latest exhaust technology. Then let's move one step further back. Here we see the drive shaft going into a differential. And then it's locked at the rear. We can lock it longitudinally and laterally so that all the axles are really locked. Right now, we're measuring with the longitudinal lock engaged. We don't need the lateral lock because we're starting straight ahead anyway, so we can actually see the correct power transmission. So just once again, the drive shaft or something like that, you can see what a massive chunk that is. Of course, there are real forces at work here and a lot of power is being delivered. But let's just wait and see, and take a look at the initial measurement. Andre has now done the initial measurement. Really awesome car. It makes a lot of noise here on the test bench. I'll show you the values real quick now. Just briefly, because people always get confused between wheel power and engine power. So what we've actually measured now is what arrives at the first driven axle at the rear. You can see the torque curves down here now. The blue and the red are both 11th gear, gear 11, and the green one is 10th gear. As you can see, when it's in 10th gear, it actually has an additional 100 Newton meters of torque. Up here you can see we have the peak power. The upper curves show the peak power. Now you can see the green curve up here. We now have a wheel power in 10th gear of 346 horsepower. This is now exactly what we have actually measured directly at the wheel. You can also see the wheel for this for some visual context. In terms of torque, we measured 1,850 Newton meters here. So it's interesting because the truck should actually have a total of 2,300 Newton meters. We measured about 500 Newton meters less at the wheel. That's what I was saying, because of the long drive shaft, because of the transmission, that's where we lose it. And now we've only measured 350 horsepower at the wheel as well. So you see the truck loses from the engine to the wheel about 120 to 130 horsepower. So there's a ready-made formula for that. Axle shafts, outboard planetary gears, 6x4, 6x6 chassis. So the more drive shafts and transfer cases that I have in the system, the more I lock all of those components up, the more actual power loss I am going to end up with. So if I had the engine in a completely normal 4x2, I would also have at the rear axle at the wheel, here as well, 200 Newton meters. The curve would already be higher. 200 to 300 Newton meters, simply because the power loss is less. So, and again, let's go over it briefly so people can understand it. You can see it here now. This is my eddy current brake. And the power that we've measured on the diagram, I'm actually measuring over these 10 centimeters here. And so that is the value for the measured wheel torque. That's what we've actually measured now. Just for the sake of understanding, because the last axle right here, it rotates along, the roller spins completely freely. And for that reason, that one isn't included in the final calculation. We really only have to measure what arrives at the axle here. And you can just add the rest on top of that. So as I said, it has 470 horsepower, because 120 horsepower is the formula. Basically, that's what it loses. So just under 10 horsepower deviation, but that's within production tolerance. That's absolutely fine. The car has only 100 kilometers on it, so it's perfect, you really have to say. All right, we'll do it like this now. I'll quickly log the app online, and then we'll see each other at the PC. So now we're going back with our Schaknat app and logging the iCarriere. It's always the same in principle. Plug in the OBD adapter. Wait until the little light at the bottom turns blue. Then open the app. And then connect to the adapter via Bluetooth. Now you can see here, the adapter is now automatically connecting to the vehicle. Now we're going to do what we did before as well. I'm going to connect the vehicle now, and then I'll enter the license plate information. After that, I'll read the complete data set online, and then I will also see it on my PC. And we can reprogram it together. And there is also a really cool feature here, because people have been asking time and again why we don't measure in four-wheel drive mode, but with the 4-axle VGC system, it basically doesn't matter at all. We've developed a dyno mode. This automatically removes the top speed limiter and also locks the ESP for the front axle. So the rear wheels can spin freely. But I had already activated that earlier because we were driving at higher speeds. So I'll log it now, then we'll meet at the PC, and I'll briefly show you the programming. We've read out the data using the app. I've now uploaded it online. That's the cool thing about the app, that I can quickly access the data sets online. Now I'd just like to briefly explain a bit about the engine. Also regarding the programming, especially when we're working on new developments, so you can get a bit of an understanding or a little insight into how everything is set up. The OM471 engines range from 420 to 530 horsepower, the 12.8-liter engine. This is actually the first engine at Mercedes-Benz to feature the third generation of engines. Because this is basically the bread and butter engine. 420 horsepower, 2100 Newton meters, 450, 2200, 480, 2300, 510, 2500. and the strongest 530 has 2600 Newton meters. The engines, injectors, and turbos are all identical. Comparing the 580 to the 530 shows a 300 Newton meter difference, still within the standard range. So the customer said he wants to save fuel. You've seen the heavy drives as well, so that is precisely why it is important. First and foremost, we need to make the truck shift early. We need good, solid torque at low revolutions per minute, so it can get into the higher gears much more quickly, and then it will be fun to drive. I have now laid out the key points for you, and I will explain the torque curves in more detail, because that is what you will get the most practical value out of. You can see here, this is in binary, this is what the software looks like, but almost no one can really make sense of that raw data. This is in 2D, and this is what the whole thing will look like in 3D. But no one can program like that, and no one can really understand it, not even me. So we program in 2D, so you can see it here now. Here you can see the torque curve, and here you can see the corresponding RPM axis. So I'll just pull that up real quick now. As you can see here, we have a revolution range from 500 up to 2100 revolutions, and a corresponding torque of 1315 Newton meters. You'll also notice that the speed rises to 1114 and then continues up to the final speed of 2100. As we said, Mercedes-Benz 480. The OM471 has 2300 Newton meters. You can see here at 1100, it has exactly 2300. I don't know if you can see that clearly. I'll show it to you again now in the 3D version so you can see the curve. You can see here, from 836 to 1490 revolutions per minute, it is operating at almost its maximum torque. Then it drops off rapidly. That's exactly as we saw it on the test bench. So you can see it yourself. I actually have to keep the truck between 800 and 1400 in terms of torque, then I'm operating at maximum torque. The customer said that for him, it is also about making absolutely sure nothing breaks, that we are really safe there. So now we are adding an additional 200 Newton meters, which doesn't sound like much, but with a truck, it really makes a significant difference in terms of torque. So now I am going to go ahead and scale it from bottom to top. Then we'll just go ahead and do a flat increase right here. So that's an additional 200. We'll be adding a total of 200 Newton meters more. And then I also have the option available here as well to adjust it individually. So as you can see, what I always do is leave the last support point in the control unit, or the last two support points here, as original. If a truck shifts out or the revs go up high, this way it doesn't run the risk of over-revving or anything like that. Or you could even go a step further. You can also leave this last support point as original. This is the case with the 1900 series and below. This here I would adjust because, let's say, in the higher RPM ranges, a diesel engine really doesn't belong there, except maybe for accelerating out. But you can also see we actually get the most out of this area. But before that, it was quite strong, so we get some movement. You can see here now, I can adjust this individually so that you always have a nice curve here, so that it looks clean here. Don't let the torque rise too quickly or too strongly at the beginning, because that's actually counterproductive for the transmission. So really round this off a bit here so that you have a nicely flowing curve. We'll also optimize the transmission for this as well. Here I already have the advantage that it reaches its maximum torque 100 revolutions earlier, as you can see here. So the truck also has the option to shift up already at, let's say, 1200 or 1300 RPM. To shift into the next gear. And it's clear, a very simple formula. Every revolution needs a filling. Low RPM means low fuel consumption. So of course, but you also shouldn't forget low RPM with low load. So if I go and say at 800 RPM, if I'm heading into a hill, going full throttle at 800 RPM with 40 tons, that's not what the inventor intended. So the truck won't be able to do that either. Even though it would already have maximum torque there, we also have to consider things like inertia, cooling, lubrication, and water pumps. With little load down there, let's say 70 to 80% throttle, that's no problem. But of course, when you really get into the mountains, it's definitely better to downshift, because even in terms of fuel consumption measured on the test bench, it's actually counterproductive. All right, that's how we're going to fill it in now. You'll see on the test bench, we'll measure about 200 Newton meters more in the motor generation 3. Now I'm calculating the checksum, uploading it online to the app, and then we'll head over to the truck and I'll show you how to reprogram it using the app. So we're in the development office and have reprogrammed it directly. I've uploaded it online and we're flashing the file onto it. I also wanted to quickly show you again. First, we open the application and then we connect using the Bluetooth feature. The ignition was already on. I left it on right away. Now we're going back into the engine control. We said we want to set it to 200 Newton meters, and I've now uploaded it for the customer as an eco-optimization. But now we're going back and doing the eco-optimization. You can see it here. That's how it's programmed in the background. For that, it's important that we do the engine first. We always do the transmission as well. Then this here, we also set that to eco. Now you can see the green check mark is there. Now it has already optimized the engine and transmission. And what's still really cool now, because I also tell people, by now we already have the error codes for Mercedes-Benz included as well. Up here at DTCs, you can see here, you can read out all the error memories. Especially control units, and at a nice speed too, so it goes quickly. So now you can really select the individual control units here. If you have something specific now, like the driver assistance system, for example, it hasn't found any errors there. So you can also go in individually. It's a nice feature, nice to have. What you always have with you, primarily it's clearly about flashing, but as I said, more and more people are buying it from us because they simply want to read and clear error codes as well, since it's just an easy thing to do. All right, that's all on that topic. Then let's go back. Once I'm done, I close the app, start the engine twice, and then the other person already begins the baseline measurement again. My colleague, the other one, has now done the baseline measurement. Now we'll look at it together on the monitor. You can see it here now. The green curve was in 10th gear. That's what we've used for comparison. Previously, we measured just under 1,900 Newton meters. And you can see it up here in terms of torque. We have 220 Newton meters more. You can also see it here in the diagram I showed you on the laptop. We let it rise slowly up to the maximum, and it holds steady nicely. And you can see down here, it drops back down to stock. So you see top curve. 210 Newton meters of torque, just as we actually, or 200 Newton meters, as we actually set it. The truck still adapts a bit up and down as well. Of course, you can always talk about a bit of test bench tolerance, but as I said, the result is simply perfect. So just as we imagined, and the curve is already clean as well. And you can see it here from the maximum torque. It starts to drop off again slowly at around 1350, 1400. And the truck is actually supposed to, let's say, be between 1000 and 1300. That's the range where it should be operating. Up here, it's not really interesting what happens. What really matters is that in this range, the fuel consumption also goes down nicely. All right, that's all on that topic. The diagram explained once again. You saw it from the bottle. And yes, I'm quite satisfied. We've reached the end of our video again about engine and transmission optimization of an Arocs 471 engine, Euro 6E, engine generation 3. It was really fun. As you saw, we made the video a bit longer. It's also an awesome chassis. I mean, the 4-axle, I always really enjoy it, especially when there's a lot of mass in motion. Also, from a technical perspective, seeing the torque and what the actual power loss really is, I always find that super cool. That's why we said we'd make the video a bit longer, a bit more in-depth. So, as I said, it was really fun, and I hope you enjoyed it too. As I said, if you're interested in the topic of engine and transmission optimization with our Schaknat app, feel free to check out our website at www.schaknat.de. You can send us an email, give us a call, or send a WhatsApp message. We'd be happy to give you personal advice, and you can get all the information directly from us. That's why about the app, which is really being bought a lot right now, especially with the error code topic. But as you always know, customers also get an air freshener with it. When we make those nice Arocs air fresheners, then it's a great car. I include one for the customer. So thank you very much for tuning in. See you next time. Thanks, bye.